All right, this is a big problem right here. How would we convert pentanoic acid into hexanoic acid? So what we're doing is that we're starting with 5 carbons and we're increasing the number of carbons to 6, just 1 carbon difference. So I'm going to put how many carbons we're increasing so that we know what we're doing. Now there's no way that you can actually come over here and add a carbon, so don't even try to do that. It's not going to work. But what we can do would be, let's reduce the carboxylic acid to the alcohol. What do I need to reduce a carboxylic acid to the alcohol? We're going to need lithium aluminum hydride, so we're going to take lithium aluminum hydride. It comes in a solution of THF or whatever solvent you need. And after we're done with the lithium aluminum hydride, at the end of the reaction, we're going to quench the reaction. And it's going to get us the primary alcohol. All right, I'm not done. I need to actually substitute the OH for a good leaving group, for a halide, because my plan is to actually make either a Grignard that can attack CO2, or maybe I can take the halide and substitute it for a cyanide. That would be nice too. Let's go ahead and use thionyl chloride. You know that I am fond of it. Might as well use it here. We may need a little bit of pyridine, but we're going to substitute the OH for the chloride. And now that I have the chloride, there's 2 possibilities right here. Let's do the first one. In the first possibility, we're going to do a CO2 insertion. To do a CO2 insertion, I need this carbon to be negative. So we're going to make a Grignard out of it. So we're going to add magnesium turnings, and we'll probably carry out this reaction in diethyl ether, just a solvent. There, we make the Grignard. Now this carbon is a great nucleophile, it's negative, and I can add CO2. The carbon is going to attack CO2, and it's going to give you the carboxylate. And then what do? You quench the reaction. So you can quench with a little bit of dilute acid, and that will protonate your carboxylic acid. 1, 2, 3, 4, 5, 6. We have 6 carbons right there. The other possibility, let me move the paper a little bit higher. I can take the chloride and I can substitute it for a cyanide. That's fairly simple. We're going to do an SN2. So let's take potassium cyanide. We want a good SN2, so let's use an aprotic solvent, DMF. We substitute the chloride for the cyanide. So remember, there's a triple bond between the carbon and the nitrogen. And now we're going to hydrolyze the cyanide. So you see, we added already a carbon. Now we have 6 carbons. We have to hydrolyze it, and you can do it under acidic or basic conditions. Actually, let me just point there because it gives you the same. So let's do it under basic conditions. I like basic conditions. Potassium hydroxide and heat. You let it reflux for a little while. And then, of course, you're going to need to neutralize the solution. So you add dilute acid very carefully. So either one of these 2 ways is perfectly right. It will give you the hexanoic acid. And you can use either one of them. They're both correct. So now you have a lot of ways to make the exact same compound. And some of them are going to be perfectly fine. Maybe some of them will actually give you a lower yield. So you need to actually get picky on the reactions.